Space exploration has become an increasingly important area of interest for scientists, entrepreneurs, and governments. One of the most promising areas of space exploration is mining, which has the potential to bring in valuable resources and propel us further into the depths of space. So hold on to your seats because in today's video, we will discuss everything about space mining. Just like Earth, planetary bodies like the Moon, Mars, asteroids, and comets all have significant amounts of valuable resources. So naturally, researchers and businesses are interested in this, hoping they can one day be mined to sustain a space economy. However, establishing any kind of mining business off of Earth will definitely be a difficult task. The first thought that might come to anyone's mind is, what resources exist in space? There are a few resources that are plentiful and valuable when it comes to space mining possibilities. Iron, nickel, gold, and platinum group metals are abundant in some asteroids and can be used in electronics and buildings. Helium-3 is found in the lunar regolith, which is in the rock and soil, and could one day be a helpful resource if nuclear fusion is successful and widely adopted. An oxygen extracting method has been created by the British company Metallysis from the lunar regolith. On the Moon's surface, there are permanently shadowed craters close to its poles. Meteors, asteroids, and Mars' surface are also believed to contain ice. This could be converted into oxygen and hydrogen and used as a propellant to sustain life. One of the most significant advantages of space mining is that it could provide us access to scarce or non-existent resources on Earth. For instance, some asteroids contain vast amounts of platinum, a valuable. By mining these asteroids, we could potentially unlock a new source of platinum that could be used to drive innovation and development on Earth. But how exactly would space mining work? Technological developments in the space sector are driving the possibilities for space mining. Launch and operations costs fall as reusable rocket components become more common, and off-the-shelf pieces are used more frequently. Private companies are now emerging as leaders in developing new space activities, a catch-all term for endeavors like orbital tourism, manufacturing, and mini-satellites providing specialized services. These activities were previously limited to government contract missions and the delivery of telecom satellites to orbit. With a market value of $400 billion, the space industry could reach $1 trillion by 2040 as private funding soars. Commercial space mining will obviously need to work on a much larger scale than scientific digs to be profitable. A single space mining enterprise would need to be able to handle hundreds or thousands of tons of material, as opposed to all samples so far consisting of less than 1 ton. Of course, space mining is not without its challenges. When reduced to its most basic components, a space mining operation follows a similar process to a terrestrial mining operation: prospecting, extraction, processing, and delivery to users. However, the peculiar features of the environments in space make this development much more difficult. Most potential mining sites in space have little to no atmosphere and are subject to sharp temperature variations between shade and sunshine. Radiation permeates the space environment and poses a danger to electronics and human health from both the sun and cosmological sources. The list of challenges goes on. Equipment must withstand extreme acceleration and acoustic forces when launching into space, which is a demanding procedure. All space missions can only carry a small payload because of orbital mechanics and the enormous energy needed to travel great distances. Deep space missions work in microgravity, which makes mining asteroids difficult or in reduced gravity on the Moon or Mars. Even celestial bodies' surfaces present difficulties for mining equipment because they are made of regolith, an unconsolidated, rocky substance, rather than the more common soil. Additionally, space mining has several legal and ethical considerations, particularly regarding issues like property rights and environmental impact. One inevitable thing in the near future is that what's found in space will stay in space. The best chance of launching space mining is through the backing of crewed and robotic exploration with on-site resource utilization, possibly on the Moon in the 2020s and Mars in the 2030s. Building moon bases out of materials found nearby could significantly decrease the amount of mass needed. In addition, spacecraft traveling from low Earth orbit to geosynchronous orbit or deep space may be a ready market for water-derived propellant if it is developed at a reasonable price. Despite all the challenges, however, space mining remains an exciting area of research and exploration that has the potential to unlock a whole new era of space exploration and innovation. Who knows what discoveries we will make as we delve deeper into the cosmos and unlock the secrets of the universe? What are your thoughts on this? Let us know in the comment box below.